Alright, so for this video, we're going to be working on our unit circle. We're going to talk about the 30, 60, 90 degree special right triangles and go from there. Now, I always like to start with a circle that is easy to work with, so paper, generally somehow to fold. Mine, yet again, comes from a very cheap paper plate where I've just cut out the embossed part of it. The first thing you're going to do is take your circle, fold it in quarters, so fold it in half and in half again, so that you can get your X and Y axes on there. So I have those in there. And remember, when we're talking unit circle, and what we're talking about is all circles are similar to each other, so we can control what we want by size of them, changing the radius. The easiest number to work with in math is the number 1, because it's got all kinds of special properties of you can multiply or divide by it, and it doesn't change the number that you have. It's a smaller number. It will cause us to have to work with fractions, but fractions are not as bad as a lot of people like to think about them. Remember, we're always going to start with the positive x-axis when we're measuring our angles, and we're going to go counterclockwise, and quadrant 1 is the first quadrant that we talk about. So that's where everything's positive. Quadrant 2 is the x is negative, the y's are positive. Quadrant 3 is the lower left, where we have everything is negative, both the x and the y's. And quadrant 4 is the last quadrant, where your x is positive and your y is negative. Remember, a radius is always a distance, and it will always be positive. It could go in a negative direction, but it will be a positive because it is a length. We're going to always start with our center is the origin. So this is 0, 0. We will label the coordinates for the x and y when we start working on the paper, as opposed to how we're measuring our angles after we get some folding done in there. Remember that this is 0 degrees. Put it here. And if we go all the way around the circle, we have 360 degrees. Yet again, thinking with quadrants, each quadrant is worth 90 degrees, so this is going to be our 90 degrees. And then if we go all the way over here, we have 180 degrees. I'm going to put that right about here. And then we have 270 if we go all the way 3/4 of the way around the circle. Yet again, now I have 4 sections. I'm talking the whole circle, so 1/4 of the circle gets me 90 degrees, 2/4 gets me 180, 3/4 gives me 270. Remember, we can also think of, so angles can be that turn on the inside going counterclockwise. We can also think of a circle in terms of its outside edge, or the arcs, or the circumference. Remember, the circumference is pi times the diameter. If I say that the radius is 1, that means the diameter is 2 radii, which is 2, which will give me the circumference of the circle to be 2 pi. And when we're thinking of that outside edge, those arcs, we can start thinking of the radians in terms of radians of the circle. In which case, this is going to be 0 radians, or if we go all the way around the circle, that will cover all of the circumference. It will cover all of the arcs, and this will be 2 pi radians. All right, and then yet again, we're thinking about this. If we do half of the circle, this will become pi radians. I will put it right here. Okay, and we're going to actually deal with that top half for a bit. If I only get halfway across that top half, it is going to be take that pi and divide it in 2 pieces. So this will be pi over 2 radians. Okay, and if I think about counting in pi's over 2's, so this is 1 pi over 2, 2 pi over 2's, 3 pi over 2's will be down at the 270 degree mark. 3 pi over 2. And now any one of these comparisons can be our way, or a ratio of converting from degrees to radians or radians to degrees. However, we usually pick the easiest numbers to work with. So a single pi and the 180 is usually the ratio that we're going to work on when we're converting between degrees and radians and that stuff. I will say, thinking in radians will make your life a little bit easier. It does require you to think in fractions. However, fractions are not as bad as people like to think they are. It's always the number of pieces that we're counting or that we have, and the bottom, the denominator, is always the number of sections we are making. So we are going to take our circle, And we're going to do a little bit of special folding because we're going to want to think of 60-degree angles. So our 30, 60, 90s, and I know if I have 180 and divide it by 3, so if I can get this broken into 3 equal parts, each part will be worth 60 degrees, or it'll become pi over 3, and we'll talk about that in a second. So the way that we can fold to get thirds is a little bit tricky. The way that I think about it is the old-fashioned water glasses, water cups from certain water companies. And then what we're going to do is try to make sure that we have them as evenly as possible, make sure that the top is as straight as possible, lining things up. This is not as easy as possible. You can use a protractor, but you know, folding has its own benefits. And remember, this is just a reference, so it does not have to be completely perfect, but the closer you can get, the better it will be. So I have my sides pretty well lined up. They're a little off, but not too badly. I've got this side right to the edge, and I've got my inside pretty much as close as I can get it. The thinner the paper you have, the easier it is to do. Yet again, if you are a little bit compulsive, you can use a protractor to measure these angles out, but I'm going to fold it right now, flatten it. I can see it's a little off, but it will serve its purposes, so it's roughly a third. I'm going to fold these lines a little bit better so that I can trace them, because I have found that if you fold paper and then put your pen in it, it makes nicer straight lines, and I don't need a ruler for it. Okay, so we're going to ignore our axes. We're going to put in those lines. Okay, so I have traced these in a red because I really don't want to be thinking of those X and Y axes right now. I do need the X, but I don't want to think of that Y axis because that Y is splitting my angle in half. All right, so we're looking at half of the circle. So this is our pi. And if we notice, I have 3 sections. So 1, 2, 3 sections. So each one of those is going to be that pi divided by 3. So this is going to be pi over 3 radians. And then the next red line is going to be my 2 pi over 3. Because I'm really talking those 3. Keep in mind, we're not counting the y-axis. 2 pi over 3. 3 pi over 3 gets me to pi. And then this will be 4 pi over 3. And then 5 pi over 3 will be over here. And then 6 pi gets me all the way up to the top. Now, the circle really helps us get that curve, gets us that similarity so that we can know that all of the triangles that we're going to be working with are going to be similar to each other, meaning the sides are going to be in the same proportion and the angles are going to be equivalent, but they're not always going to be the same size. So we're going to have our radius is going to be 1 yet again. So I'm going to say r equals 1. And what I need to do is get my right triangle in here. I'm just going to use quadrant 1 yet again. And I'm going to go from the point that we have all the way down. We're going to put our coordinates down after we look at this triangle. So just a second to draw that. Okay, so remember we have the radius is 1. We have that this angle right here is going from counterclockwise from here to here is going to be my 60 degrees. So if I label all of them thinking my degrees, this is 60 degrees, this is 120 degrees. Okay, going from here to here is 120. And then we have the 180, and then we have the 240. And then we have the 300. And then we have 360 if we want to label all our degrees in there as well. Now, we do have a 30, 60, 90 triangle, because if this angle is 60, I have my 90 degree angle, and I can go all the way up to the top, and that will be 30 degrees, because all the angles of a triangle have to add up to 180. So this is the 30, 60, 90, and then I have to remember the one property that I remember with my 30, 60, 90 triangles is the short side is half the hypotenuse. As a reference, we will put, we'll see how this works. Just some information that I have about my 30, 60, 90 triangles. I do know that the hypotenuse is twice the short leg, or the short leg is half of the hypotenuse. I know a lot of people don't like fractions, but in this case, the fraction is going to be what we use. We're going to label our sides with what we have. A lot of times when I'm thinking with my unit circle and my 30, 60, 90s, I'm worried if I have a tall triangle or a fat triangle or a wide triangle is what I usually think. And in this case, it's a tall triangle that I'm talking about. So the long side is the y value. My short side is going to be my x value. Remember, we have x and y's. Points are always, coordinates are always x comma y. And in this case, my radius is 1. So that means my short side, which is going to be my x, is going to be 1/2. Okay, and for this triangle, I need to find my y equals, and we can do that on the back of the unit circle, looking at my Pythagorean theorem. So I know that Pythagorean theorem is a squared plus b squared equals c squared. Or in our case, because we're talking on the xy axis, I have x squared plus y squared equals radius squared. And I know that my radius is 1, so I have a 1 squared. I know I'm looking for my y, because that is my height. And my x squared is going to be half of 1, which is 1 squared. Now, remembering our algebra and our arithmetic of how we square fractions, the square of fractions is the square of the top over the square of the bottom, or multiply straight across. When we have the fractions, it's 1/2 times 1/2. This will be 1 squared is 1, 2 squared is 4, and then I have plus y squared equals 1 squared is 1. And then I have to just solve my equation, subtracting that 1/4 from both sides. So this will look like y equals 4 over 4 is equivalent to 1. Write it as a fraction with the same denominator, minus 1 over 4. Okay, so I know that y squared, don't forget your squared, equals 3/4. And now I'm going to square root both sides. Remember, when you square root, you do have to remember positive or negative, but because we're talking an actual physical thing, triangles, we know that we're going to only need the positive because we're talking lengths of a side of a triangle. So I'm going to square root both the top and the bottom. So square root, square root, square root. And this will give me y equals the square root of 3 over the square root of 4 is 2 over 2. So all of our right triangles with the 30, 60, 90s are going to have those sides in the ratio of 1, 1/2, and square root of 3 over 2. So this is square root of 3 over 2. All right, so putting this on our paper so that we can get all of our coordinates out here. Remember, our positive x-axis is 1, 0. We now have the coordinates of this point here, which is my pi over 3, which is going to be the x is the 1/2, and the y is the square root of 3 over 2. Okay, because it's just a right triangle, thinking about it with using the sides. Pythagorean theorem is a great thing. I do have my y-axis, which is 0, 1. And then I have another 30-degree triangle, 30, 60, 90 over here. It is a tall triangle, which means my coordinates are going to be the same as they are in quadrant 1. The only thing that changes is my x in quadrant 2 is negative. So this is going to be negative 1/2. And square root of 3 over 2. All right, and then we do know that the negative x-axis is negative 1, 0. Quadrant 3, I'm going to have that same pi over 3 reference angle, so it would still go up to the x-axis, have that same triangle. And in this case, my x and y are both negative, so this will become negative 1/2. Negative square root of 3 over 2. Okay, which we can almost see on my paper. Okay. kind of. I have to glue it down, but. And then my negative y-axis is 0, -1. And then we have this other right triangle, and we can draw the triangles in there if we want, of the 5 pi over 3, which is still a 30, 60, 90 triangle if I'm thinking about the triangle that you can draw. And this, the x will be positive, which is the 1/2, and the y will be negative, square root of 3 over 2. All right, so that is the 30, 60, 90s. So this is the pi over 3s. However, that triangle doesn't have to be tall and proud. It could be a little bit lazy and going actually longer than higher. In that case, it's going to be the 30s at the unit circle part, or at the vertex. And to get that, we're going to take each one of these 60-degree angles, or the pi over 3s, and we're going to split them in half. This becomes a little bit trickier. Honestly and truly, the easiest way to do it is to bring your x-axis to your 60-degree line, and fold that way, and then do it each one, because chances are you're not exactly center if you did it with folding. So I'm going to fold it like that so that I have those, and I'm going to do that all the way around. Okay, so I traced them with kind of a purplish color. You can't really tell a lot of difference from that and the black. In any case, those are going to be my 30-degree angles. And if we look at this, now we're talking the whole circle, the top of the circle. And I now have 1, 2, 3, 4, 5, 6 sections that I've broken, counting the y-axis and all that stuff. So these are going to be my pi over 6s. So this is pi over 6. Which equates to my 30 degrees. Okay, and then, so this is pi over 6, 2 pi over 6, which reduces to pi over 3, 3 pi over 6, 4 pi over 6. This one is going to be 5 pi over 6, which is going to be 150 degrees. Cool. And then this is 6 pi over 6, 7 pi over 6, which we will label. And that is going to be 210 degrees. So 7, 8 pi over 6, 9 pi over 6, which becomes 3 pi over 2. 10 pi over 6, which becomes 5 pi over 3. 11 pi over 6, which is 330 degrees. And then I'm back up to 12 pi over 6, which is the 2 pi. All right, so this is a little blurry, maybe a little closer. You can see all of my labels pretty much where we have it. Then we are going to do the same thing. We're going to draw a right triangle down to the x-axis using whatever I have for a straight line. Drawing, yet again, left-handed works well. And with my purple, I'm going to try to get this as exact as possible. All right, so we now have a second triangle. This one is a lazier one, so it is wider than taller, but it is still a 30, 60, 90 triangle with my radius equals 1. And yes, I know this gets a little bit busy. If you want, you can just have the 30-degree angles on here. However, I like to have both. So my radius is 1. In this case, I know my short side is opposite my 30-degree angle, which is my smaller one. So this case, this is my 1/2. And the Pythagorean theorem is going to work the same way. My longer side is going to be my x. So as I'm putting the coordinates here, lining things up with what I had, that means that my x in this case is going to be my square root of 3 over 2. And my y this time is the 1/2. Okay, so it's the same values. So the 30, 60, 90s, the coordinates are is going to be one of them is going to be 1/2, and one of them is going to be the square root of 3 over 2. Square root of 3 is bigger than 1, so that has to be the longer side. as we're looking at it. Yet again, I do not memorize the unit circle. I am thinking of these triangles and what their sides are. It tends to work a little bit better if you memorize the unit circle. You have to draw the whole unit circle to be able to use any of the information. With knowing how those triangles work, you can make small sketches and recall what you need to know for the information, and it's a little bit faster, a little bit easier. Everything becomes clear. However, nothing becomes clear immediately, and it takes time and practice, and I do recommend thinking about this and trying to visualize those triangles as you are working problems. I will try to explain that as we do more work. So over in quadrant 3, I went over further. So that has to be the negative square root of 3 over 2. And then I went up less, which is the 1/2. Remember, positives and negatives. In quadrant 3, I'm looking at this triangle. So I went over further. So it is going to be negative square root of 3 over 2. And then I went down less, which is the negative 1/2. Okay, last quadrant, I'm looking at this point here. So I went over further, down a little bit less. So this is going to be the square root of 3 over 2 and the negative 1/2. All right, so the signs are going to depend on the quadrants. The coordinates are going to depend on which triangle we're dealing with. But that is how I get all the values and think about my 30, 60, 90s into a unit circle so that I can use those ratios in later topics.